This is the screencast for section 6.1, example 4. We're going to look at unit vectors, and much like the unit circle, which has radius of 1, unit vectors have a magnitude of 1. A unit vector is any vector v divided by its own magnitude. In other words, if you take the reciprocal of the magnitude, so 1 over the magnitude, and multiply by the vector, you will get a vector pointing in the same direction, starting at the origin, that just has a magnitude of 1. Now I created a diagram down here so you can do your own proof of why that actually works using the Pythagorean theorem. I'll give you a hint. Start out with v squared equals a squared plus b squared and try and get an expression that equals 1, that contains the vector ab in the numerator and its magnitude in the denominator. In this section we have the introduction of the standard unit vectors I and j. I is the horizontal vector of magnitude 1 and j is a vertical vector of magnitude 1. Basically any vector a comma b can be expressed as a coefficient times I plus a coefficient times j. Visually you can see what's happening here is if the horizontal vector I of magnitude 1 gets multiplied by a, the horizontal piece of vector v, and then the vertical vector j of magnitude 1 gets multiplied by b, the coefficient or vertical piece of the vector v, their sum is going to equal the vector v, which is a comma b. And algebraically you can see what's happening here. Example 4 asks us to find a unit vector in the direction of v, which is negative 3 comma 2, and verify that it has length of 1. So in other words, this is vector v. I'm looking for another vector along vector v that's a little bit shorter that would have a magnitude of 1. In order to find that vector, I have to take vector v and divide it by its magnitude. So first I'm going to find the magnitude of vector v. Since vector v is in standard representation, I can just take the square root of its x-coordinate squared plus its y-coordinate squared, which I get square root 13. Therefore the unit vector will be negative 3 comma 2 vector v divided by the square root of 13, or times the reciprocal of its magnitude. So I get that unit vector is going to be negative 3 over square root 13 comma 2 over square root 13, which is approximately equal to negative 0.83 comma 0.55, which looks like it would be about a vector that would be pointing in the same direction, just definitely smaller than vector v. Well, the second part of this says we need to verify that this vector would have length 1. So now I need to find the magnitude of this new vector. So I took its x-coordinate squared and added its y-coordinate squared. The square root of all that would be, in fact, magnitude 1. The now try problem number 21 asks us to find a unit vector in the direction of the given vector. So negative 2 comma 4. I'm going to use magnitude first. And I get 2 square root 5. So now I need to take that magnitude and multiply the vector u by its reciprocal. So I found that the unit vector would equal negative 1 over square root 5 comma 2 over square root 5, or rationalizing the denominator would be this. Then in my calculator it's about negative 0.45 comma 0.89, which, as mentioned in the introduction, can also be written as negative 0.45 as the coefficient to the unit vector I, plus 0.89 times the is the coefficient of the unit vector j.